Hi guys, and welcome to problem 416, which is about thinning. So this is very interesting because essentially this is the only exercise we really have on thinning that we're doing this time around. So it's a pretty good idea to use this opportunity to talk a little bit more about thinning. And let us just ignore the exercise text for a while and talk about just thinning in general. So what you see here is the formula for how to express a thin version of a stochastic variable n star. Now, in which setup do we normally use this? Well, there is one case that I would like to mention for you. Case 1, which is this. So let n star denote the number of claims. Or you know what? Let it denote the number of accidents. I prefer to think of it this way. If you buy a bike insurance, I don't know how we do this. So if you buy a bike insurance, is it something like that? Oh. Anyways, if you buy a bike insurance, then maybe there is a deductible on 1,000 kroners, right? So that means if the damage is above 1,000 kroners, then the insurance company pays for the excess. If it's below 1,000 kroners, then you pay yourself. So let n star be the number of accidents that this guy who buys a bike insurance encounters. And let n be the number of claims paid by the insurance company. So that means if this guy goes out and gets himself hit by a car 4 times, and the different losses for each time are respectively 1,500, 500, 7,000, and 1,200, then that means in this case we have that n star is equal 4, whereas n, which is the number of claims paid by the insurance company, is then only equal to 3, because only 3 of these claims exceed the deductible, and the insurance company will never hear of the third claim. Now, what do we have that is quite interesting here? One question that we may ask ourselves is, what can n be if we know n star? So if n star is 4, can n be 5? So if we have 4 accidents, can we have 5 claims paid? No, that's not possible, because you can only pay at most as many claims as there are accidents. On the other hand, this inequality goes both ways, which means if we know that this guy has had 3 claims paid out, he can't possibly have had only 2 accidents. So n star is always greater than or equal to n. Now, why do we call n the thinned version of n star? Well, let us just write this up using this notation. If we write this up using this notation, then n is equal the sum of i's for I ranging from 1 up to n star, where it is assumed that each ii is Bernoulli distributed, or as in the book it's called simply binomially distributed, with success parameter p. What does that mean? That means that with probability p, this will be equal to 1, so equals 1 with probability p, and it equals 0 with probability 1 minus p. In this case, where we're looking at an example with a deductible, then p is equal to the probability that a claim size exceeds the deductible, which is 1,000 here. So what we are doing essentially is we're flipping on light switches, or we're adding yes-no variables. If I is equal to 1, then this claim that then a certain accident will also be a claim paid. If I is equal to 0, then a certain accident will not become paid because it won't contribute to the sum that n is made up of. So this is the basic thought behind thinning. Now, just one more thing we need to include is we need to include that I is so that the i's are IID, so they're independent of each other for I different from j. And this plays a pretty big role because what does this mean? Well, this tells us that that n, given that n star is some value little n, well, that is the sum of i's for I going from 1 up to little n, right? This thing here is the sum of IID Bernoulli variables. So that means that this thing here is binomially distributed with parameter n comma p. And what this means is, given that we know there is a certain number of accidents, so given that we know there is a certain number of accidents, then the number of claims, so then the number of those accidents that are actually paid is given by asking, is the first accident paid? Is the second accident? So it is binomially distributed. We will come back to this a bit more later when I go through the formula that's in the book together with you. But this was just an intuitive understanding of why thinning is the way it is. And in the next video, we will take a look at the formula in the book and try to understand why it works the way it does.